Hello friends, welcome to Susan and John MathTube. So we are working on complex integration and we are doing application type 2. So you know that type 1 is polynomial divided by polynomial where the degree of the denominator is at least 2 bigger than the degree of the numerator. But in type 2 it is different. It will be polynomial by polynomial, but the numerator will get multiplied by sine or cos. In the last video, we did one problem with sine, and in this video, we will do another one with cos. By the way, be aware of integral with limits 0 to infinity. So if you get 0 to infinity, you can be almost sure that in your exam, they will give an integral which has a property half times minus infinity to infinity. So when you write the last answer, don't forget to multiply by half because it's a long process. At the end, don't forget. So always check whether the limits are from minus infinity to infinity. If not, if they give you 0 to infinity, be aware of it at the last minute. Anyway, I hope you're good with this method. So all you have to do is you have to replace this cos with our exponential function and the usual dialogue. I'm not going to waste your time by writing that dialogue, but in examination, it is a must. You have to draw the contour, you have to write the dialogue where C is blah 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 etc. So you know what to do? Replace x with z and replace this cos or sine with e to the power whatever be the value here. And I hope you remember the convergence condition. Degree of numerator. Here the polynomial in the numerator is 1. So the degree will be 0. The polynomial in the denominator is of degree 4. So the degree condition is working. And second thing, the denominator will never become 0 by plugging in real number. So the convergence conditions are working. And the limits are from minus infinity to infinity. Perfect. So I'm going to evaluate the integral that I wrote, not the question. Okay, but in exam, don't forget to draw. Okay, so the singularities are z equal to, you already know this question, so the singularities are plus IA, z equal to minus IA, z equal to IB, and z equal to minus IB, and all of them are symbol pole. But I am not interested in all of them. I am interested only in plus IA and plus IB. By the way, in the question it was given A is bigger than B is bigger than 0. That means A is bigger than B and B is bigger than 0. So definitely A and B are positive. If they do not give that condition, the orientation will flip. Okay, now what do? All we have to do is we have to find the residue of the poles above the axis. So R1 plus equal to residue at z equal to IA, which is a symbol pole. In the examination, make sure your presentation is neat. Okay, so that will be limit z tends to IA, z minus IA multiplied by this function. So e power I 2z divided by z plus IA, z minus IA, and z square plus b square. Will the shortcut that we learned recently work here? No. There are three methods: series method, the limit method which I am doing now, and the last method that I introduced can be used only for polynomial by polynomial. Anyway, this is a classic method. So I'm going to plug in the limit. So it will be e to the power I 2 IA divided by IA plus IA, apple plus apple is 2 apple, and then I square, A square plus B square. Okay, I hope you remember I square is, come on, what's I square? Minus 1. And here we go, this will become e to the power minus 2a divided by 2ia, and this will be minus. It becomes minus a square plus b square. So look at this. How do you write x minus y in case you want to flip it? Can you write this as y minus x? Yes, provided you put a minus outside. So this is b square minus a square. Currently, I'm going to write this as a square minus b square. So I'll put one negative. So it ends up like minus 2a divided by 2ia into a square minus b square. If you want, you can leave it as such. Anyway, I like a square minus b square. Residue 2. And that will be limit z tends to ib, z minus ib. The same story. Pause the video and try it. Pause the video and try it so that you'll feel more confident. Anyway, I got the answer e to the power minus 2b divided by 2ib multiplied by a square minus b square. Comment below whether you got the same answer or whether there is any change. Now, look at this. So, the integral that I created, okay, now look at this. So, the integral that I created, not the question, not the one they asked, but the one I created, that is e to the power I 2z divided by z square plus a square multiplied by z square plus b square dz, where a is greater than b and a and b are both positive numbers, is equal to 2 pi I sum of the residues. And the first residue was minus e power minus 2a divided by 2ia a square minus b square plus e to the power minus 2b divided by 2ib multiplied by a square minus b square. I hope you got the same answer. Now let's simplify. So 2 pi I can see something common. So that's in the denominator. So I'll write it in the denominator. 2i a square minus b square. And then minus e power minus 2a divided by a plus e power minus 2b divided by b. Now I want to write the positive stuff ahead. So this will get cancelled. So pi by a square minus b square multiplied by e power minus 2b by b minus e power minus 2a by a. If you want, you can take LCM and simplify further. Anyway, I'm stopping with this. Now once more, a warning. If you stop here in the exam, you may or you will lose marks. Because come on, they asked something else. They asked me to evaluate a real integral. They asked me to evaluate minus infinity to this stuff, not the one that I found. So I'm going to write like this. Integral over c e power I 2z divided by z square plus a square into z square plus b square dz equal to this thing. The contour is from minus r to plus r and the region above the x-axis. So I'm calling it c plus. So this integral can be written as minus r to r e power I to x divided by x square plus a square x square plus b square dx. Why did I write x? Because it's in the real axis. Plus c plus. What do you mean by c plus? The portion of the contour. Contour means the total thing above the x-axis. And that will be e power I 2z divided by z square plus a square z square plus b square dz is equal to pi by a square minus b square e to the power minus 2b by b minus e to the power minus 2a by a. Okay, now what will you write? Cauchy's lemma or Jordan's lemma? Jordan's lemma. So you have to write in the exam very clearly and search online what is Jordan's lemma. In your examination, write the statement here. And by Jordan's lemma, you have to write when r tends to infinity. In type 1, we will write by Cauchy's lemma. But remember, Cauchy's lemma will work when r tends to infinity. And we did one special problem. Do you remember? The singularity came in the x-axis. So Cauchy's lemma will work when r tends to infinity, when r is small also. But Jordan's lemma will work only when r tends to infinity. In Jordan's lemma, there will be exponential function and a polynomial. In Cauchy, it will be only polynomial. Okay, anyway, this will disappear. And this will become minus infinity to plus infinity. Anyway, the end of the story is the answer will be equal to this thing. Now, wait a minute. Presentation is very important. If you write directly, they will not give you mark. And one more thing, sometimes they want to trick the students, so they will ask like 0 to infinity or minus infinity to 0. So don't get worried about it. All you have to do is you have to apply the doubling property. Anyway, I'll be back with the third type and one more very serious problem in type 2. So till then, my friends, bye.